Welcome to Kubernetes Basics for Developers course. In this module, we'll talk about another core concepts of Kubernetes, which is services. Let's get started. Networking is an important part of Kubernetes because as we deploy our pods to our clusters, we obviously need to talk between the pods potentially and need to talk from the outside world into some of these pods. So in this module, we are going to take a look at services, and that's what they are all about. So we are going to start off with the core concepts of services and what they are used for. We'll talk about several different service types that are available in Kubernetes. Learn how to create a service with kubectl. Then we are going to create a service with YAML, and we will show how to then deploy that with kubectl as well. So far as where are we in the overall infrastructure here? We are obviously down now in the service area. We're going to talk all about how pods get their IP addresses and can communicate and much more. So let's talk about some of the core concepts related to services. So Kubernetes defines a service this way. A service provides a single point of entry for accessing one or multiple pods. Now, to dive into this more, let's ask a question then. Since pods live and die, can you rely on their IP addresses? So let's say that we have an external caller, and that calls into a front-end pod with an IP address and a container, and then that calls some backend pod. Well, what if one of those IP addresses changes because the pod actually goes down and has to be replaced? So to answer, of course, to this question is no. We can rely on an IP address of a pod, and that's what we need. That's why we need services. IP addresses changes a lot as pods changes. So when it comes to the life of a pod, we know that pods are mortal, if you will, and they may only live at a short time. Now of course that depends on the pod. You could have pods that stay around for a long time, but you just never know. So you can't rely on a pod IP addresses staying the same, because if the pod gets rescheduled and comes up as a new pod, it's going to get a different IP address. We also know that pods can be horizontally scaled. So as that happens, of course, a new IP address would have been initiated to that new pod. And another important thing to know about IP addresses and pods is that a pod only gets its IP addresses after it has been scheduled. So there wouldn't be a way for a client to know about that IP address in advance. Therefore, we need a better way to work with this, and that answer of course is a service. The goal in life of a service is to abstract that pod IP address from consumers. So if you take a look at the left hand image here, we have the service at a fixed IP, but then it's going to know how to talk the pods behind it. Now you will notice the yellow labels, my app. We talked about labels in the previous module, creating deployment section. Labels are really important here because they are going to be used to associate pods with the service. Now as the service comes up, we can rely on that IP address, but the behind the scenes working of the IPs of the pods, that's going to be handled by the service. So if a pod dies and new one comes up, this service will know that IP and it's going to know how to load balance between these pods, which is a built-in feature. Now, as mentioned, it does rely on labels to hook up the service and pods. So we are going to see that again as we move along. And earlier in the course, we talked about the big pictures of Kubernetes. We saw that worker nodes have a kube proxy, and that's what creates a virtual IP for different services that are running. Now this uses layer 4, which is TCP IP. Pods can be ephemeral, but services we need to have them sticking around, because that is the thing that a client on the outside world or another machine or a worker node would know about. Now what services do behind the scene is create something called endpoints, and that's what sits between the service and the actual running pod. Now these pods might talk to some other set of pods, and that would be done through a service, and in this case we have backend as our label that would be trying the service to the pod that you see. You can see that services play a really important role in Kubernetes. I mentioned that services do load balancing for the pods. So if a service is tied to multiple pods that have been replicated, then that service can do load balancing between this based upon the connection that's coming in. So for example, if an external caller calls in, and then the first pod here might get it, and then the another calls comes in, then the second pod might comes in, and so on and so forth. And this is what it will do behind the scenes for you. Now with browsers, it's a little bit unique. What will happen with the browsers is, because they use the same connection over and over for the request to the server, that will be respected by Kubernetes, and that one connection would keep hitting the same pod. Of course, if that pod goes away, then that can be rescheduled and the service can then deal with that. Now let's wrap up this core concept discussion here. That's a lot of networking in Kubernetes. So we are going to touch just one core concept, because as a developer you definitely need to know these basics. So the goal of this module is to kind of break the gently to how services work, how you can create them, different types of services, and so on. Now having said that, let's keep moving on and let's talk about the different service types that are available in Kubernetes. To work with services in Kubernetes, you need to know about the different service types, and that's we are going to talk about in this section. So when it comes to service types, there's 4 main types. We have the default type, which is called ClusterIP, and this makes it so that a service can talk to internal IP addresses and set those up for your pods. We also have one called NodePort, and this is where we will have the IP address for a node and then set up a static port on that node that we can call into. We can also have a load balancer. Now this would sit in front of our different nodes and then provision an external IP to act as that load balancer to call into the nodes and then ultimately call into the pods. And finally, we can have an external name service that maps a service to a DNS name or IP address. So let's dive into a little more detail about these different type of services. So the first one, ClusterIP, is the default as mentioned, and this exposes an IP address internally within the cluster. Now that this will do is you will have a service that sets up, and we know that service can talk to the different pods, but the service itself is just going to be used internally within the cluster. So only pods within the cluster can talk to that service, but it does allow pods to talk to other pods. For example, in our cluster we might have a service with these two pods, and those pods now need to talk to these other services you see here. A cluster IP would enable this type of scenario, and so this is very common, of course, because the external would oftentimes only needs to talk to maybe one or two services, let's say. But behind the scenes we might have tons of services with their associated pods that we then talk to. Now the next type of service is a NodePort service. This exposes the service at the worker node's IP, and it's going to have a static port assigned. Now this will automatically allocate a port by default, although you can override that, and you can see the ranges here. And what will happen is that service will then make it so that we can proxy through that node into the pods behind the scenes. So it looks like this. Let's say we have a node and we have exposed a NodePort service on the port 30100 that you can see here. Now behind the scenes we also have these pods that we want to talk to. So with the NodePort service, an external caller can now call into the IP address of the node and that port 30100. In this case, then we can talk to the behind the scenes service that are set up, and the pods and everything else that might have, and that's what a node service does. So this one's actually very useful for few reasons. Number one, we could set this up so an external caller could call in, and that's useful. But as a developer, oftentimes we might want to run some types of external call for debugging purpose or maybe performance reasons. So knowing how we can proxy into a given pod using a NodePort service is actually really valuable, and we will see more of this as we move along throughout this module. Now you probably heard or maybe even implemented load balancers in your company. Load balancers of course are important because as a call comes in, some nodes are busier than others, and we might want to route to different nodes based on the traffic. So a load balancer service exposes the service externally, and it's really useful when combined with a cloud provider's load balancer. So whether you are going to use AWS, Azure, GCP or some other cloud, they will definitely have their own type of load balancer. And then Kubernetes has its own type as well. In fact, it has several you could use. That's my tiny service one. That's the default one that I will show you, and others even that are available. So what will happen here? Then in the behind the scene we will have NodePorts on the nodes that would be set up for us by this type of service, and then internally on those nodes we know we have ClusterIP services as well, so that would allow the outside world to call in each node. Then once it gets called, it is going to proxy that into the internal cluster services. Now if a new request comes in, that might load balance to a different worker node, and then that would call into other services behind the scenes. So you can see it's kind of combination of all this. We still have ClusterIP services behind the scenes, but then we also have a NodePort type service on the nodes that are set up, and then the load balancer service itself will know how to talk to those. Now the final type of service we are going to look at is called external named service. So this set up a service that really is just an alias. So we know As we know, a service sticks around and we can count on the service's IP address. What we are offer is we want to call some other domain, maybe within the company, maybe outside of the company, who knows, or IP address. But let's say that domain or IP address keeps changing on us, and we now have to keep updating the containers in the pods that we want to talk to it. Well, this would allow us to define a service once that can then proxy request to this external service. And that way, if external service DNS or IP address changes, we would just update this service. That way our client stay unaffected. So in essence, the external service is just hiding the details from the actual cluster of what we are actually calling out to externally. So it looks like this. We might have a service internally which is maybe just a cluster IP service, but then these pods might call an external name service. Now of course that acts as really just a proxy between some external service out there. As I mentioned, if that external service changes happens, we just update the external name service, and we don't have to impact all the pods and internals that are calling that service. So that's a look at the main types of services from Kubernetes. So let's take a look at how we can actually work with services and kubectl. Kubectl provides a port forwarding command that we did look at earlier in this course. But now we are going to dive into a little bit deeper and see what's going on with it and what it does behind the scene. So if I were asked the question, how can you access a pod from outside of Kubernetes? The initial answer would be you can't, because by default everything is set up as a cluster IP. But with port forwarding you can do this. Earlier we saw this kubectl port forwarding command that can be used to forward a local port to a pod port, and it looks like this. We can say port forward and give it the port name, and then we had the external port and the internal port. Now you can also use this with deployment. So if we had a name deployment there, then we could say, alright, let's go into that deployment, and in this case I am going to use 88 for everything. In addition to that, we could port forward to a service and expose that on port 88 so that it calls into the services ports doing it in this way. So let's take a look at how we can use this in a few different ways. So let's open our VS Code. Earlier in this course we looked at a tiny service DPL deployment, and this had tiny service and it runs container port of 3000 internally, and in this case we have two replicas, and let's go ahead and deploy this. Okay, let's see with the get all. Let me expand a bit. So we have two pods up and running, and here we see two available pods from our tiny service deployment. And notice we have a cluster IP here, and you think you might be able to pull up a browser and just use that, but that won't work here at the moment. So right now the only thing we have is a cluster IP set up for our different services. In fact, our pods here don't really have a great way to talk to them at this point. So what we can do is we can use the kubectl port forward command to work with this. So let's copy from here, and then the port, let's say we use the same internal and external port. Okay, alright, so now if you open the browser, So localhost, and if I add port 3000 to my localhost, and you see our app is up and running and you can browse it. Alright, now what? That's going again. It's opening up port 3000 on the node, and that then proxies into the pod, and now we are able to talk to that pod directly. Otherwise, if we turn off, watch what happens here. Refresh. It's not available. What's happening is we are trying to hit localhost 3000, but there is no port 3000 that's been opened at this point. So no proxying goes on to that port. Okay, coming back to Visual Studio Code. Now if we do k get deployments, and we do run our port forwarding command, but this time we will do with deployment. So k port forward deployment slash, in this case our tiny service TPL, and port 3000. Let's hit our localhost 3000. It's up and running. Right. So that's for now. Next we will create service through our YAML file. Let's get going. We can use YAML to declaratively define services that can be deployed to our Kubernetes cluster. And that's what we are going to jump into in this section. So first up, we have looked at YAML quite a bit up for this point, and know that if we are going to deploy a service, we could do a port forward, and that would be one option that actually is a service behind the scenes. But if we want to do it declaratively, then we will have to create a separate YAML file, and then we will have to do create or either apply that service using kubectl command, and that of course would generate the service that can then add IPs for the different pods we have behind the scenes. Now the YAML for a service is actually pretty straightforward. You give it an API version like normal, and you give it a kind of service. Now we have seen kind of pod and kind of deployment. Now it's time for kind of service, because obviously we are dealing with services in this section. So that part's pretty straightforward. Now you can also have metadata, and that would be things like the name of the service, any labels you want to put onto the service, and then you can have a spec for the service, and you can give it the service type. The default again is a ClusterIP. You can give it a selector. This is what would be used to actually select the ports that this service would apply to, and then of course you can define ports. Now there's two types of ports. You have the port that you can call into the service, and the port that it would target one, for instance the container running in the pod. So here would be a simple example of a cluster type service. Notice again we have the API version, we have the metadata. Now this time there's a label there where you could put your key value pairs, maybe tiny service, other service, or other types of labels. Now we also have the selector, in this case app tiny service. Now that's going to apply though to any other pod or deployment that has app tiny service. So if we deployed the pods through a deployment YAML file, then as long as the template for the pod had the selector app tiny service, then this service would automatically apply to that. It kind of hooks itself to any pod that has that label. You'll also see that we can define the container target ports, in this case 3000, as well as the port for the overall service. In this case it's 80 as well. Now, one of the interesting things about service is the name that you give them in the metadata section. So in this case we have name tiny service, and if you look at the bottom, there is another name other service that gets its own DNS entry within the internal DNS in the Kubernetes clusters. Now that's great, because instead of having to memorize an IP address or something like that to get the service which is then calls the pods, you can just use tiny service, other service, or whatever name you decide to go with for the name of your service. So in this case, a tiny service pod could access this by using just the word other service, and then call it whatever the port is, and then we could call into that, and now you don't have to worry about the IP addressing, memorizing those and blah blah. It takes it much easier because IPs first off aren't the easiest to work with, especially if they changes. Services we know don't change once they're created, but why would I want to worry about actual IP address where I can actually reference it by name? Now you can choose, you can do it either way. This one is a NodePort service. So you will notice that in this case we have the type set to NodePort. The same features we talked about in the previous examples apply. We have a selector that selects all the ports that are app tiny service, and then we have our target port and our port. Now notice the NodePort there at the bottom. Now that's optional because it will assign one dynamically, but if you want to specify one in that range, then you can go ahead and put it. In this case it's 31000. Now we already seen something like this in practice with our port forward command, but now we are officially creating service that would act as a NodePort service. Now the next type of example is for a load balancer. Now it's going to be the same thing, except for in this case we have type load balancer, we have our selector, and then the port that you see. This would be the external port. So it would be our for instance localhost 3000, and then the target port of what this is actually going to call into. We're assuming would be 3000 also here. So we set this to load balancer, and then from there we can now call port 3000, and if we had tiny service which runs on port 3000 behind this, then we could call directly into that port through this load balancer. Now the final one is the external name service, and this is where we are in a sense going to create an alias. I named it external SVC, and that way any pods that need to get to this service, instead of going to api.otherservice.com, as you will see in the external name down below, they instead can just call external SVC, and then it will proxy them to the other one, to the external name that you see here. And that way we will have to do is update this YAML if that api.otherservice.com ever changes. Very nice, because it keeps it very clean. And then again you also notice a port here. So when the ports call into this, it would be external SVC 5000 ports. Now let's see how we can get this YAML into action with kubectl. Let's take a look at how we can run our kubectl commands to get services going, but also at how we can communicate between pods and the process that happens behind the scenes with that. First, let's check our current pods. So, okay, get pods. So you can see we have 2 pods up and running through our last deployment in this section. So we will create a new pod here through our YAML file, which is already exists in our source code here. So pod.yml. Let's do the apply and create a new pod here. Okay. So our pod been created. Now let's check how many pods we have at this point. Okay, get pod. Alright, so this is our new pod that we have created here. Now what I would like to do is show you how we can actually talk between this, and then how we can actually change that a little bit by using services. In fact, we are going to use the YAML that you see right above. Before we do that though, what I am going to do first off is I am going to go into the pod, and let's go ahead and we are going to run the kubectl execute command on that pod. We need to install the curl inside our pod first so that we can run curl commands. To do that, I already have a script file here, so we can follow these steps. But before that, we just get into our pods first. Okay, so you will run the k execute and then the pod name. Alright, so let's get into the okay. Now we are inside the pod. Now we'll follow the above steps. First, I will write and update. It will take some time. Okay, it's done. Then let's install the curl inside this pod. So apt get curl. Okay, it's installing. Okay, so you can see curl is already the newest version here. Alright, so now if you are first time installing, then you may run this command to clear here. Okay, now our curl is ready. Now we need to know the IP address for the pod. Okay, alright, so first we create another PowerShell. Okay, then we get pods. So for example, we will be getting IP address for this pod. To get that, we can do a couple of ways, like so we can describe, or in this case we can use kubectl get pod and then copy and then YAML. Okay, alright, so that's our IP. Can copy ClusterIP. Now we get back to our original PowerShell. So here, if we do the curl now, HTTP our IP address 10.1.0.163 and it's a port we used. Yep, bingo, it works here. So now that works fine, but only problem is every time you need to go some other way or around, and or either way you need to remember the IPs. But if the port goes away and recreated, then IP will be changed. So in this case we cannot depend on IP addresses. To solve this problem, we can have the service here. Let's create this service here. Okay, so let's run kubectl. Where's our service YAML file name? Service.yaml. Let's create the service. Service created. Let's verify that. Services. Here you go. So our tiny service ClusterIP service is up and running. Also notice the IP address here 3005 as per our YAML file. Now let's test this if we can communicate with other ports within this with the help of this service. So let's go back to our previous PowerShell, and within that port, then we let's do the curl HTTP 10.97.25.24 and our port was 2005. Yep, here you go. But this time we are talking to ports within the services. But if you keep continuing doing the curl, then actually behind the scene it will do the load balancing. Alright, now if we go back to the another PowerShell, okay, here you see we do have the name, which basically is the DNS name though. So instead of remembering this IP, we can use this name and get our result as same as with IP. Let's try that out. So we go here and then we do curl HTTP tiny service star IP and then the port. Right, we need to define our port since it's not the default 80. Right, so we try again. Curl HTTP tiny service IP 5. Here you go. Alright, let's get exit and we see some other service types. Alright, so first of all I will be clean up the existing services. Okay, get services. Yep, so then let's grab this name from here and we will do delete. So okay, delete. Let's check again. has been deleted. Right, now let's create our NodePort service through this YAML. Already have created a file here, so you can see above. So let's create that. So okay, apply f NodePort.service YAML. Yep, it's created, and you see here the NodePort is 31000, and this one basically will call this port and then target port as well. Okay, now let's get our services. Get service. Yeah, here you see the newly created service, our NodePort service, and the cluster IP is this. But on the right side, you notice here, this is the external port, which basically will talk to our this targeted 3000 through this 3005 port. Right. Alright, since the service created, let's test it. So if we open our browser and we localhost, then we use the NodePort 31000. Yeah, bingo, it's working. Alright, so that's all about the NodePort service. Let's clean up and we move to the next part. Alright, so we will delete service, copy this and paste it. Up, it's deleted. Now we will move to the our load balancer servicing. Right, let's create our load balancer service. So okay, service.yml. Alright, let's create our load balancer service. Let's create it. So okay, get services. There we go. Alright, so load balancer service created. Let's test, and this time it will be 30005. Yep, it's working. Throughout this module, we have talked about some of the basics and networking features that Kubernetes provides. We know pods live and die, so their IP addresses change, and services then provide that abstraction that allows us to get to the pods without actually having to know the IP addresses of the pod. That way, the consumers can just call into the services, and that magic happens behind the scenes with Kubernetes. Now we associate a service with one or more pods through labels. Labels, again, could be used to organize resources possibly, so that you can query them, group them, things like that. But in this case, labels are really important, just like they were in deployments to tie these two things together, the service and one or more pods. We also talked about there's 4 main types of services, and we also try to show some demos. So that's all for today. Thank you for watching. Hope to see you in the next module. Cheers.